Hey everybody. Today we're talking about frequency distributions. We're in a situation where we have a bunch of quantitative observations, just a list of numbers, like this one right here. And we'd like to get a feel for that data, in particular to say intelligent things about the shape, center, and spread. But unless the set is extremely simple, we aren't going to get far just by looking at it, and we need to summarize it somehow. One of the most fundamental tools at our disposal is the frequency distribution. And this is just a table that's obtained by breaking the data down into a reasonable number of classes and then listing the number of observations in each class. So, for instance, with that data that I flashed a moment ago, we can do this frequency distribution. Here I've made 5 classes and just counted up how many observations are in each. So, for instance, between 11 and 14, including 11 but not 14, we have the observations 11, 12, 12, and 13. Notice that the classes all have equal width, that's normal, and that none of the classes overlap. That's essential. Boundary values like 14 are always included in the higher of the two classes. So the class 14 to 17, not the class 11 to 14 in this case. That's also very typical. Already we can say some smart things about this data set. We can see that the data is centered around 18. The middle class from 17 to 20 has 11 observations. And we can also see that the data is fairly symmetric about that center. We can see there's about 9 observations below that category and 10 above. So to construct a frequency distribution, we have to follow this 4-step process. First, we have to decide how many classes to use. And there's no hard and fast rule for that. That's a human decision. But typically, between 5 and 20 is reasonable. If you're in a college-level stats class, oftentimes your professor will tell you how many classes to use. Next, you need to compute the range of the data, which is the difference between the maximum and the minimum values. You then calculate the width of the classes by dividing that range by the number of classes. And you should always round up, and we'll see how that works in just a moment. Then you find the lower boundaries for each class. Start with the minimum in your data set, then add the class width repeatedly until you have the right number of starting class values. Then to get the upper class values, you end just below the next class up. So then you just have to count how many observations fall into each class. All this gets more clear when we do an example. So let's do that using this data. There's 50 observations here, and I want to make a frequency distribution with 8 classes. So the first thing I do is to get the range. I take the maximum value here, 115.5, and subtract off the minimum value, 52.0, to get a range of 63.5. If I'm going to use 8 classes, I'm going to divide that range by 8 to get 7.935, and I need to round that up to 8. This ensures that when I make 8 classes, I actually capture every single one of the observations. All right, now I'm going to have 8 classes, each of width 8, and the minimum value in my data set is 52. So to get the lower class boundaries, I'm going to use 52, and then 52 plus 8, and then plus another 8, and so on. So 60, 68, 76, and all the way up to 108. Then the upper class boundary for each one of my intervals is going to be the same as the lower class boundary for the next one up. And I just make sure I get my inequalities straight so that they are inclusive on the left and strict on the right. After that, we just count how many observations fall into each range. So I won't put you through the whole counting process here. Suffice it to say that in this data set there's 11 observations that are at least 52 and not greater than 60. There are 8 that are at least 60 and not greater than 68, and so on. Again, these classes do not overlap. Boundary values like 60 are always placed into the next higher bin. Also notice, just as a quick check, that if we add up all these frequencies, we get 50. That should always be the total size of the data set. Frequency distributions are frequently used to create visualizations like this frequency histogram. That's a whole longer conversation, so I won't go into it deeply here. But you can see that the height of the respective bars are corresponding to the frequencies that we had in that table a minute ago. It's also often helpful to expand a frequency distribution. So we already had these classes and the frequencies. So I've added a few more pieces of information here that can be helpful depending on the sort of plot you might be wanting to make. The midpoints of the classes are going to be exactly halfway in between the lower and upper boundary. The relative frequencies are going to be the frequencies divided by the total size of the sample. So for instance, in that first row, we have a frequency of 11. The total sample size is 50. The relative frequency is 11 divided by 50, which is 0.22. Finally, cumulative frequency is often helpful. Here what we're doing is we're just adding up all of the frequencies in the classes that come before. So for instance, in that second category, from 60 to 68, the cumulative frequency is 11 plus 8. And then in the next category, it's 11 plus 8 plus 9. When you've done that, you've got a few quick checks to make sure you did it right. For instance, the total relative frequency should be 1, just as the total frequency should be the total n in your sample. Finally, the last cumulative frequency value, in this case 50, should be the total number of observations.